I would like you to take a few seconds to close your eyes, and I'd like you to maintain the first image that comes to mind when I say science. Great, now you can open your eyes. What was it that you pictured? Did any of you visualize the typical old white-haired man, such as Albert Einstein? What about this mental image? A science researcher sitting at the bench performing lab work. But did any of you imagine a group of scientists working together? No, if you did not, that's understandable. In Western cultures, our perspective views about science often focus on the regular, singular, brilliant scientists who make substantial contributions through their innate genius. However, scientific talent is not inherent. It is cultivated through many hours of training and effort. Moreover, teams, not individuals, conduct most scientific research. Thus, the illusion of the brilliant individual scientist largely fails us when attempting to understand how STEM fields meet true success. Another overlooked detail is diversity in relation to teamwork and its applications in STEM fields. Diversity makes us different, yes, but diversity also makes us smarter. I did not quite understand this ideology either until I was invited to attend a weekend STEM program hosted at Georgia Tech, ecstatic to delve into 2 full days of science-based activities and seminars. Our group leader engaged the student with STEM-related challenges, their purpose being to develop the STEMist that resides within us. Believe me, I was confused too. However, there was a specific challenge that to this day I still replay in my head. For this task, the majority of the students in my group stood in the middle, and 5 subgroups of 3 individuals were selected to be the engineers of the challenge. Our group leader gave us a challenge that followed along the lines of this. With your group, create a human model that illustrates how the Coriolis effect is founded in physics. The first to finish the challenge won. One of our group members was an exchange student from Australia, and unusually fascinated with the Coriolis effect, seeing as she'd always been told that in the northern hemisphere, water being drained rotated in a clockwise direction instead of a counterclockwise direction. She further explained to the group that the phenomena led to the deflection of an object's path due to the rotation of the Earth. Our second group member, a 12th grader from a local Atlanta high school, who was currently taking physics, with a now better understanding of the topic on hand, was able to connect that the deflection of an object moving north or south occurs because the planet's surface moves much faster at the equator than at lower and higher altitudes. Because all the locations on Earth complete 1 revolution every 24 hours, and because the Earth has a greater circumference near the equator than near the poles, its speeds of rotation vary due to the effect the radius of an object has on the tangential velocity of the object's circular motion. Now that the conceptual aspect of the challenge had been accomplished, understanding the connection between physics and the Coriolis effect, the next step was to design a human model. My group was stumped to say the least, and I personally did not feel to be contributing much either. As a sophomore, the highest level of science I had taken was advanced placement chemistry, not yet having taken any physics classes, which in this challenge put me at a disadvantage. That is, until I reached an epiphany. I was the only one in my group to have been in marching band, and I suddenly remembered how much I always despised being towards the extremities when in a rotating circular line, and how I was required to march much faster than those closer to the center of the line in order to assure that the line remained straight as we rotated. With this idea in mind, I enlightened my teammates on my personal experience, and as a team, decided to take the group in the middle to model a marching line of students rotating along a fixed axis, a student that was simply marching in place. And we explained the reasoning as to how the varying speeds at which each student marched as they stood further from the center of the line related to the conceptual physics that the Coriolis effect is founded on. However, the point is not the fact that my group and I won the challenge. Instead, it is why we won the challenge. It's because my group possessed a key component, diversity. I was not diverse because I had been the only one to participate in a marching band. Diversity refers to difference. As such, diversity is a property of groups, not individuals. An individual cannot be diverse, but groups of individuals can possess diversity, whether it be physical or cognitive. But why is this trait so crucial when working in a group, especially in STEM-related fields? Diversity enhances creativity. It encourages a search for novel information and perspectives, leading to better decision-making and problem-solving. My small group each contributed a different experience, perspective, and knowledge that the other did not personally possess, and was ultimately the main reason as to why we were successful in our endeavor. Even simply being exposed to diversity can change one's ways of thinking and how to prepare when engaging with individuals whose cognitive styles differ from your own. This is not just wishful thinking. It is a conclusion I have drawn from spending nearly every day for the past 3 years with the most diverse group of people I know, the 12th grade cohort of Paulding County High School's Academy of Science, Research, and Medicine. Thank you.